Now let's use our equation that we got in our previous step to predict y. So when we're given an x, we're going to use the equation, not just the graph, but the equation to predict y. A couple of vocab terms that we're going to run into along the way are extrapolation and interpolation. Key parts are the x and the in. Extrapolation is predicting y when x is outside the range of available data, and interpolation is predicting y when x is inside the range of data. So just to give you a quick example of what that means, if I wanted to make a prediction about the year 1993, 1993 is between my max and my min. So I could do that. That would be interpolation, is inside the max and min. Any number between 1986 and 1995 I could do interpolation on. Extrapolation would be picking a number that's smaller than our min or bigger than our max. So if I wanted to make a prediction about 2013, that would be extrapolation because it would be outside of the range of my data. Going down here, use the regression equation to predict the winning length for the year 2000. Decide if this is interpolation or extrapolation. Well, we have this equation up here that says y equals 0.485x minus 932.707. So our prediction is that y is equal to, again, 0.485, and in this case, x is the number of years. We had x as the number of years when we made our equation. We're going to use the year 2000 as our x. So that's going to become x. So times 2000. And then minus our 932.707. So minus 932.707. And we want to pull out our calculator to actually go ahead and do this. So 0.485 times 2000 minus 932.707. And when we do that, we get 37.3 if we round it off to one decimal, just like these are, 37.3. So our prediction then is that in the year 2000, the winning length of a zucchini, that's what we're doing, winning length of the zucchini will be 37.7 inches. The reason that this is going to be extrapolation is because the year 2000 is beyond our max. Our max in this is 1995, and we are outside of that. So that's why the year 2000 is extrapolation. Next what we're going to do is use it to predict the winning length for the year 1994. Even though we have data for 1994, we know it's 34.4. Let's make a prediction with our line and see how close it comes to the actual data. Same thing. Y equals our slope, 0.485, times our year, x, which in this case is 1994, is going to be x. So times 1994, and then we're going to subtract our 932, our y-intercept, 932.707. Get our calculator back out, same thing. 0.485 times 1994 minus 932.707. We get 34.4 is what it would round to. 34.4. If we look at our exact result, we got 0.383. It rounded off to be exactly the same as the length that they measured here, 34.4. So it turns out that our prediction was very, very accurate. But why is it that we had a little bit of this rounding error, 0.383? That's not exactly 0.4. How could that happen? The reason that that can happen, and sometimes it can actually be quite a bit off from the actual data, is that when you have these predictions here, these points that we're making a prediction based on, it's not a perfect correlation of 1, r equals 1. Usually r is going to be a little bit less. And if we look up here, we had an r of 0.8. That means that sometimes these points are going to follow a little bit of an imperfect line when we're making our our pattern. So it's not always going to fall on what we predict, even though in this case it did pretty darn good. In this last part, we're going to make a scatter plot of our data points, similar as we did earlier. Now it has some extra instructions here, but on looking at this further, I want you to scratch these out. I don't think that this is going to help us make our graphs. We're going to get rid of these instructions here, and I'm going to give you some new ones. So let's start with that scatter plot. First thing is to write our years down here. And what this had to do with was kind of the numbering down below. So this first box was going to be 1985. So 1985. And then 2 down was going to be 1987. So we're just going to relabel this and make this a little bit clearer and use the actual year. So that's 89, 91, 1993, and then 1995. And going back to our data, we have 1986 is the first year, and we have 31.8, so almost 32. So we're going to make a little dot right there. 87 the next year with 32.9. And conveniently, all of these years are in order, so I can just kind of go down the line as I plot these. Otherwise, we'd have to be a little more careful. 30, 32.7, 34.2, 33.6, 34.5 up here, 36.3, that was a big zucchini that year, 34.4, and then our last one in 95 was 35.5, so up here. So you can kind of see an overall trend where they're getting bigger every year, but some years they spike up real high, and other years they can kind of drop off the pattern a little bit low. So let's draw ourselves a line through these. I also realize that this point right here, this 30, I actually misplotted that. The 30 is way down here, so be careful as you make your scatter plots because there are plenty of opportunities to make mistakes. So this point is way down here. Next thing I'm going to want you to do is to try to plot your regression line. And the best way to do that is not necessarily using your y-intercept, because your y-intercept is way, way, way off the map. Way far away. Because we have 1,985 is where we started our graph. So our y-intercept is a long distance away. So what we're going to do instead of using the y-intercept is we're going to plot 2 points on our graph. 2 predicted points. I'm going to do this in a different color, and you can just make sure you're marking it a little differently with your pencil. And then we're going to connect the points on those lines. We already made a prediction with one of our points. In 1994, so in the year 1994, on one end, we had a prediction of 34.4. So that's right around here. Let's go ahead and pick one on the low end. So let's say 1986. Let's make a prediction down on the lowest end of our data. So if we plug in to our equation y equals 0.485, this is our slope from our equation, times the year 1986, because I want to find out what's in this spot right here, 1986. And then we subtract 932.707. We plug it into our calculator. 0.485 times 1986 minus 932.707. We end up getting 30.5 for y. So the y comes out to be 30.5. So go up to 30 and a half, and we're going to get it right there. The reason I picked the year 1986 and the year around 1994 and 1995 is you want to pick a point kind of on each end, on the far ends, and that'll help you draw the straightest line. So now that I have those, I'm going to get my line tool and connect them. So I grab my line and draw it straight through here. So you can draw a straight line all the way through. And now I've got myself, and if I extend it a little bit this way, that's my line of best fit. That's the line that most accurately predicts the winning length of the zucchini each year. Notice how even from the picture, it's not necessarily what I would have drawn just looking at the picture. You have to trust that the numbers are going to work out a little bit better for you than just your picture. So don't draw just what your eye sees, because sometimes that can be a little bit deceiving. Do what the calculation says. Pick 2 points, plug it into the formula, get your two estimates, and then draw a line that connects those points. And that's how you can most accurately draw a regression line.